Hi, my name is Anthony Ligori, and I'm a distinguished engineer within AWS, and I work on the EC2 virtualization stack, including AWS Outposts and AWS Nitro. And I'm super excited to be here today to talk to you about AWS Outposts and bringing the AWS experience on premises. In this talk, we're going to talk about what an outpost is, why is it interesting, why might you want one for your own local data center. We're going to talk about how to order an outpost and what the install process looks like after you've decided that an outpost is right for you. Then we're going to talk about how it works under the covers. We're going to actually talk about some of the hardware, some of the innovations that we've made that made this all possible, and then what's happening at the software layer under the covers. And then finally, we'll wrap up with a number of the really exciting customer use cases that we've seen since launching the service in reInvent 2019. One of the things we like to joke around about in AWS is that after we launched EC2 in 2006, our very first feature request was, how do we bring EC2 on premises, right? Customers have been asking about on-premises compute and finding ways of helping to run workloads that for whatever reason can't move into the cloud, either due to latency or data locality reasons. And we honestly just hadn't been able to figure out a good model to do this that would preserve the things that we thought were really important about being cloud native. Finally, in 2018 or so, we figured it out. We figured out how to deliver a truly consistent experience on premises. And there's really three things fundamentally that we think are absolutely critical about achieving that consistent on-premises experience with the cloud. And we're able to deliver all of those things with Outposts. The very first one is it's absolutely crucial that you use the same infrastructure on premises that you would use in the public cloud. In the last 15 years, we've spent a lot of time optimizing hardware and really developing our virtualization stack purposely for a specific set of hardware. And there's just no way to have that same experience without using that same exact hardware. And because I'm ultimately an engineer at heart, we're going to talk a lot about hardware, and I'm going to show you lots of fun pictures of the actual hardware and talk about how it works, because it's near and dear to my heart. The next thing that is absolutely critical is that an AWS Outpost is fully managed, monitored, and operated by AWS. What we heard from customers and what we knew was super critical was we didn't just want to give them a piece of software and tell them, okay, now you have to operate it, you have to patch it, you have to monitor it, you have to figure out when something's going wrong, because that's ultimately not what the cloud is. With the cloud, you launch an instance and you only worry about your application. You don't worry about the underlying infrastructure. And so we thought it was absolutely critical that we deliver something that we could remotely manage and monitor and really take that responsibility off of a customer's plate so that they can really focus on their applications. And then finally, one of the things that's absolutely great about AWS is the ability to manage everything programmatically, not just with AWS's own tools like the AWS CLI and all of our various language SDKs, but also through a really rich ecosystem of third-party tools, things like Terraform and tools like that. One of the things we wanted to make sure of is that when we deliver a AWS experience on premises, that all of that same tooling would just work. If you have gone and built, CloudFormation stacks to run your applications, we wanted those CloudFormation stacks to just work. And likewise, if you instead were using Terraform, your Terraform template should still work on this capacity. And with Outposts, we're able to deliver all of these things. And we think that it's the thing that makes it truly unique compared to what other options you might have for on-premise computing. Like I promised, we're going to look at hardware. And so this is the first of hopefully a number of different times that we'll look and talk about hardware. But what you see on the right-hand side of the screen, this is an AWS rack, and this is an outpost. So when you order an outpost and it gets delivered into your facility, you're getting a full rack like this. And these are the same racks that we land within our own data centers. In fact, really the only difference between this rack and what we have in our data centers is that we generally don't do doors. We talked to a lot of customers in the early days with Outposts, And one of the pieces of feedback they had is that a few customers really wanted to have a door with a lock, and so we made sure to include a door with a lock. But the sameness is really important, and this is really fundamental to how we think about Outposts. It is the same Nitro or AWS control plane. It's the same underlying hardware. It's the same software running on that hardware. And by combining all of these things, what we can really provide a consistent experience that's the same as you would get in the AWS region. And that's really important to customers. Okay, so I said I wanted to talk about hardware. Let's really kind of dive into it. So this is a close-up of an actual Outpost rack. And there's some things I wanted to highlight about the rack itself that we haven't really talked a lot about in the past, but I think it's one of the things that's really easy to overlook when evaluating a product like this. So we've talked about the servers and the Nitro cards within the servers and why it's important to use the same hardware. But one of the things that's kind of unusual for some customers, and it's something that I think has been surprising to a number of Outpost customers, is that we actually deliver a full rack that's fully cabled, and this is how it comes from the factory. Like this is what you're receiving. And this is actually really important. So besides the fact that the cabling is actually quite neat, if you've worked in a data center, you probably most racks don't look like this from a cable management perspective. But like one of the things I wanted to point out is that if you see the black cables on the screen that are coming from each of the servers, those are 100 gig network connections. And so we're bringing an awful lot of networking out of every single server. And these are special cables, so they actually bifurcate, and some of the lanes go to one of the switches. There's 2 switches in the rack, and some go in the other, and this allows for failover between switches. But the really important thing is that you're able to get full 25 gig networking in this rack. A lot of data center equipment you buy today, it almost always is 10 gig, if it's even above 1 gig. And so one of the things that a lot of customers take for granted in AWS, because they've just become so used to it and it's just become an expectation, is that I can launch multiple EC2 instances and I don't really have to think about where those instances are, where they land, and I can get full 25 gig network performance between those 2 instances. And I can get consistent low latency. And if you're used to working in sort of traditional data centers, one of the things you probably know is that if you just choose 2 random servers that are located in different rooms or something like that, I mean, even achieving 10 gig of networking between those is very unlikely unless you've worked with your networking team and you've kind of designed from the very beginning to support that. But with every single AWS Outpost rack, when you're doing networking between 2 servers, you're always getting that high network performance and that super low networking latency. And one of the really cool things about Outpost is you can actually order multiple racks, and we'll interconnect those racks together, and you get that same consistent networking experience across racks too. And so really the way we think about Outpost is that you're not just getting a server or a single instance, but you're getting that full experience that includes not just the compute hardware, but also the networking experience too. It's not just networking, though, when it comes to infrastructure that's important. One of the other things that I wanted to talk a little bit more about is power. And we've talked a little bit before about how we do centralized power conversion, but there's really a couple super important things about this. The first is availability. So we spend a lot of time making sure that EC2 instances are really highly available, and that even though we tell customers to design for failure, because as Werner likes to say, everything always fails, we still want to make sure that every single instance has the best availability possible. There's 2 ways to do this. One way is that you can double up power supplies in every single server, and this is not uncommon within the industry. The problem with this is it's super inefficient because smaller power supplies are actually much less power efficient when it comes to converting AC power to DC power. And 2, it adds a significant amount of cost. And so sometimes if you're trying to optimize for cost, what you'll do is you'll avoid doing 2 power supplies, you'll only do 1, and then you're introducing an availability risk. And we really don't want customers to have to make those kind of trade-offs. And so a key aspect of our overall rack design is that we have centralized power conversion. This allows us to use bigger power supplies that are far more efficient in power conversion, but it also allows us to have redundancy without having to put redundancy in every single server. What this means is that you get the best of both worlds. You get highly efficient power conversion, but you also get high availability in your power conversion. And the key to achieving this is by having this DC back rail that you see in this picture, this large kind of metal bus bar. This is something we've been doing for a long time in AWS. It's actually very common now among hyperscalers. You'll almost never see this in traditional data centers though. And AWS Outpost is unique in that we're not just giving you a piece of software that you run on some kind of random piece of hardware, but we're really bringing you the full AWS experience all the way from high-level services like RDS to low-level things like power infrastructure. And that's really key to how we think about delivering the AWS experience on premises. So we've talked about why the hardware is interesting and kind of what our goals are in building Outposts. And now you've maybe decided I would like to have an Outpost in my own data center. And so what does that look like and what does that entail? So the very first step in acquiring an Outpost is placing an order. To do this, the first thing you do is define a site. And a site is really a physical location. And so you'll tell us the address of the location, but also things like power requirements. For instance, does your data center have single-phase power or is it three-phase power? Do you have DC power? Do you actually have a DC power infrastructure? They do exist. People do that out there still. What about your network configuration? Is it 10 gig? Is it 1 gig? Is it 100 gig? Can you support BGP? All of these things that will ultimately help you figure out what the right Outpost configuration is for your environment. And then finally, a lot of customers maybe don't deal with entire rack deliveries at a time. And one of the things we've found from experience is that we have to sometimes help customers with planning for the actual weight of the rack and getting from the shipping dock to the final location. Sometimes doorways are a little bit too short. Sometimes it's the door jamb. Like I've literally been in a data center before where the pathway to the data center had a door jamb and it was just half an inch, well, not enough clearance because of the door jamb. And of course we can figure out ways to help customers with that and kind of work around that. The other issue that's not uncommon to see is carpets. And so there might be a hallway typically coming from the loading dock, and sometimes there's a carpet on it. And so you have to plan around, putting down plywood so that you don't tear the carpet and things of that nature. So we really just want to have that conversation with customers before they order an Outpost, because we want to ensure that the day that we actually do the install and we deliver the rack, you're going to be ready to handle it and there's no problems getting it to where it needs to be. After you've defined your site and we know enough information to help you choose the right configuration, it's time to select your actual Outpost. When you acquire capacity in EC2, you just launch instances. You might grab 10 M5 larges, 15 C5 12XLs. Within an Outpost though, because we're actually talking about servers, you have a little bit more kind of granular configurations. So for instance, a single server can typically support 2 C5 12XLs. And so you have to do a little bit more planning about how you're kind of bin packing your instance types. And so to make it easier for customers to think about this, we've predefined a number of configurations that we think have a great mix of instance types for various workloads. And those are available on the website. You can look through it, you can browse it, you can choose one that suits your needs. That said, if you can't find a configuration that suits your needs, we're more than happy to work with you to define a new configuration. It's super easy on our side, and you just have to let us know and we'll work with you on that. Finally, when you've selected the right configuration for your location and you're ready to go, you submit your order, and then the next step is that our installation team will reach out to you. This isn't just to schedule the delivery date, but one of the things that we often have found is that different data centers have different policies. Sometimes you just have to sign in, but sometimes there's security training or safety training, especially within manufacturing, where there might be robotic equipment in the facility. And so there's really no situation that our install team can't figure out a way of accommodating. And so we'll work with you, we'll work with your local security teams to figure out what we need to do so that we can safely get into your data center and deliver the rack. So now you have a rack and you're ready to start using an Outpost. And I promised that I would talk a little bit about how the Outpost actually works under the covers. So we talked a lot about sameness and about how we're using the same control plane, but really, how does that actually work under the covers? The really critical thing about Outposts is that it's enabled by AWS Nitro, and AWS Nitro is something we'll talk a little bit more about in the next few slides. But AWS Nitro is a very different type of virtualization platform than what exists and you're probably used to in your on-premises facility. One of the things that makes it really different is that whereas a typical virtualization platform has some kind of general purpose operating system like Linux or Windows that you log into and you configure and you use it to kind of bootstrap the system, an AWS Nitro server is much more like an appliance. You turn it on, it supports a number of APIs, it doesn't do anything until it's told what to do. And it's kind of very simplistic in that nature, even though it's very advanced and sophisticated. So the nice thing about it being this API-driven mechanism is that we realized that we could take advantage of this in order to create Outposts. All we really need to do is figure out a way to forward our API calls from within region through a secure communications channel to the rack that is in your data center. And from our control plane's perspective, as long as we're talking to something that speaks the Nitro APIs, it's a Nitro server in our data center. We don't really care if it's going over a VPN connection or if it's actually located within the data center itself. All we really care about is that it's responding to the APIs we expect it to. Likewise, that server that's sitting in your data center, as long as it's having APIs sent to it, it doesn't care what's originating those APIs or whether it's in that same data center or not. And so this tunneling technology that we built to enable Outposts, it's fundamentally based on all of the innovation we did in Nitro. But really it allows for that truly transparent experience where both from the server's perspective and the control plane's perspective, it's no different from being in one of our data centers. And that's really been key to the sameness. I've been working on Outposts literally since day one, since it was only an idea on paper. And even today, it still surprises me how when we try to do something for the first time on top of Outposts, it generally just works. Like even some of our higher level services that are deeply integrated into our stack, it largely just works. There are a number of things that we've had to do specifically to add new features to services to make it make sense within a customer's on-premises data center. And we'll talk a little bit more about that in this slide. So networking within an Outpost. Once you have an Outpost installed, you've launched an instance, you now might be thinking, okay, well, I know about VPC in the region. I know how VPC works in AWS. But what does that actually mean in my on-premises facility? So normally, if you launch an instance within an AWS region, you get a private IP address assigned from your subnet, and you would have an internet gateway in your route table, and ultimately that's what allows you to talk to the internet. Now, if you launched an instance within an AWS Outpost, and you tried to add an internet gateway to your route table and talk to the internet, it actually would work. It would work exactly the way you would expect it to, but all of the traffic would run back to the region through that secure channel that I mentioned earlier. If you're putting AWS in your on-premises data center, you probably don't want to go back to the region to talk to the internet. You probably want to talk to things that are in your local network. And so in order to facilitate this, we've introduced a new concept in Outposts called the local gateway. And the local gateway does exactly what it sounds like. It allows you to talk to the local resources on your network. And so now within an Outpost, when you create a subnet and you create a route table, instead of adding the internet gateway as your default route, you'll most likely add your local gateway as your default route. You can actually do both if you could do really advanced routing trickery here, but for most customers, adding a default route of local gateway is going to be what you want to do. And then within the local gateway, in order to make it easier for customers to think about kind of bringing AWS concepts into their on-premises data center, we introduced a new concept called customer-owned IPs. And customer-owned IPs are very similar to public IPs in that when traffic is egressing or ingressing from the local gateway, there's a one-to-one NAT performed. And this one-to-one NAT will translate from the private IP address of the VPC into this customer-owned IP address that's assigned from the specific pool. The really nice thing about customer-owned IP addresses is that it allows you to bring a chunk of IP addresses to the outpost. And then you can have any kind of VPC configuration within the outpost that you would like to have without really worrying about every time you create a subnet, is that going to have some kind of impact on your local network? And so QoIP is a good example of a feature where we build it specifically for outposts, and sometimes there's bits of software that now have to understand QoIP. But fundamentally, it's just a normal AWS concept. It's very similar to the Internet Gateway, and it's really just meant to be something that you can use to take advantage of your local resources in your network. I've mentioned Nitro a few times today, but we really haven't stopped to talk about what is Nitro and why is it so important and why did it enable the creation of AWS Outposts. So AWS Nitro is a system that we've been developing since about 2012. And so it's something we have a lot of experience about. And fundamentally, what we've done with AWS Nitro is instead of doing all of the virtualization infrastructure purely in software so that it can run on any arbitrary hardware platform, as is typical in most data centers, we realized early on that if we built hardware and software together very specifically for the purpose of enabling EC2, that it would allow us to make disruptive innovations within the stack. And it was this real concept that led us to building the AWS Nitro system. At the core, there's three things that really define the AWS Nitro system. The first are AWS Nitro cards. And these cards have a custom ASIC built by Annapurna Labs that enables super high performance I/O virtualization. So this is what runs VPC networking, the elastic block storage, and instance storage. And in all three cases, we're able to do full line rate encryption in VPC, in EBS, and in instance storage, all through these Nitro hardware cards. The other really interesting and exciting use of these cards is to actually act as the overall system control. And so when you think about a normal kind of commodity server, there's the x86 processor that's on the server is going to be hosting a networking stack, and that's where all of the APIs are going to be terminating. But within the Nitro system, whether it's a x86 processor or an ARM processor or something else, it's actually the Nitro cards that are controlling the overall system and terminating those APIs that I mentioned. This allows us to achieve a much better security profile because we have a hard separation between that control plane and then anything that might be running on behalf of the customer. In addition to the Nitro cards, another key aspect of the Nitro system is the Nitro security chip. And so, security is the number one thing we focus on in AWS. It is the most important thing that we do. And we really wanted to make sure that we could raise the bar as high as possible in the Nitro system and deliver the best possible security for customers. And we looked at the overall design of a commodity server, and we knew we could do better. And so the Nitro security chip is a chip that we've built, sits directly on the motherboard, intercepts all I/O to non-volatile storage, and allows us to establish a really strong root of trust from the very beginning. Finally, after all of this hardware changes, we looked at the hypervisor and realized we can actually simplify it a lot. There's just a lot that we don't need to do. We don't even need a networking stack anymore. We can just completely remove that. And that's exactly what we did. we created the Nitro Hypervisor, which is a super lightweight hypervisor that provides really just memory and CPU allocations. And the thing about software is that, especially when you're dealing with low-level system software, the less software you have, the better the performance is. It's kind of really easy to understand when you put it that way. The less software, better performance. And so with this super lightweight hypervisor, we're actually able to achieve indistinguishable from bare metal performance on top of the Nitro system. And what's really exciting with Outposts is that this is really the first time that customers can get all of this innovation that we've built in the public cloud in their data centers. The actual hardware, the full system, all of the security advantages, all of the performance advantages, you can actually have that now in your data center. And that's super, super exciting. There's also some interesting things that previously you wouldn't have seen that we've been developing, but now that the hardware is actually something that you can look at, becomes visible, and so it becomes interesting to talk about. If you've worked in data centers, one of the things you're probably aware of is that media handling can be a big challenge. It's really important to make sure that customer data is always within your control, and anytime you're dealing with hardware, you're going to eventually have to decommission the hardware. It's eventually going to leave your data center and be recycled or disposed of in some way, shape, or form. And it's critical that we make sure that the data that comes from the customer doesn't leave that data center, that you're always within control of it. Traditionally in data centers, what folks do to sort of prevent this problem is they have rigorous systems around tracking individual drives. And when you're going to decommission a server, you have to open up the server, you pull out the drives. It's a very difficult process, very labor intensive and time consuming, and it's easy to make mistakes. And so you have to spend a lot of time getting good at this. Because the Nitro system is designed from the ground up for this purpose of being a large-scale virtualization platform, we could tackle this problem in a new way. And so because we encrypt everything at rest in Nitro using hardware-based encryption, we can actually control the key hierarchy for all that encryption into a central location. And in addition to having the centralized control, we actually can externalize that. And that's what we do with the Nitro security key. So within this little device, there's a small chip. And if you can see the little bullseye on the screen, there's actually a screw that's sitting above that chip. And if you come in with a power drill or a screwdriver, you can actually turn the screw and crush that chip. And crushing that chip will physically destroy the encryption keys associated with all of the data on the server. And it's just as strong as shredding every individual drive in the server. But it also is something that you can't make a mistake on, because there's one place to do it. Different servers don't have different numbers of them or anything like that. It ends up being a very simple and elegant way of dealing with this data destruction problem in a really rigorous fashion. And so this is the type of innovation that bringing the true infrastructure on premises helps to enable and hopefully simplifies customers' lives considerably. I want to talk a little bit about some of the interesting use cases that we've been seeing on top of Outposts. One of the ones that really gets the team excited is competitive gaming. And so we've been working with a customer in Outposts who launched a large multiplayer game and was looking to significantly reduce latency for game players. If you've ever done online gaming, you know that lag is super important. And a lot of folks, if you think about the US as an example, if you're on the East Coast or if you're on the West Coast, then you can get low tens of millisecond latency to any AWS region, and that's great. But if you're in Texas, you're not going to get the best latency that you possibly could. And so what AWS Outposts enabled was for this customer to deploy a number of racks in a number of different cities and deliver super low latency to a brand new set of customers that otherwise would have had a higher latency experience. The thing that was really cool about this was that they were able to use the same tooling that they were using to deploy in region and just point that tooling at the Outpost, and it pretty much just worked, which was again, super exciting to see. Another really exciting customer to work with is Morningstar, who's a financial services company. And they had a really interesting use case that was super creative, and it was kind of really insightful that they came up with it. So Morningstar is working to move all in on AWS, and they're looking to migrate an existing set of applications in their data centers. And one of the challenges they faced is, when you have this large application with lots of microservices, how do you know which ones are latency sensitive and not latency sensitive? And so how do you incrementally move individual microservices if you aren't really sure what that dependency graph looks like? What Morningstar realized is that they could land an AWS Outpost in their existing data center, and they could use that to incrementally convert their applications into an AWS native stack. And then once that full application was converted and running on the Outpost, they could lift and shift it back into the region and really accelerate the timelines for being able to migrate their applications into AWS. This wasn't something that we were initially thinking of when we built Outposts, and it ends up being a great use case, and we're now seeing a number of other customers follow the same pattern, which has been really exciting. I've been really excited to talk today about Outposts. I thank you very much for taking the time to listen, and I'm really excited to see what customers do with Outposts in the coming years too. Thank you.